Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we are doing question 15, chapter 13C. So this is your inclined plane chapter, and this question 15, I often find that students tend to struggle with this question. So just before that, if you're not too sure on what inclined plane is, or if you're a little bit unsure of how but just before that, if you're still new to inclined plane, or if you still want to have a further understanding of this topic, I highly recommend you check out the topic video that I've made. I'll leave it in the link below or the pop-up above. Check that out first, and then you can come back to this tutorial question, and then when I'm going through it, hopefully you can understand, I guess, better than if you haven't really have a clue on what inclined plane is. So outside of that, let's get into the question. Question 15. A car of mass 1 ton coasts at a constant speed down in a slope inclined at theta degrees to the horizontal, where sine theta equals to 1 over 20. Now, whenever you're doing an inclined plane question, I highly recommend you sketch a diagram, okay? So we'll sketch that after we read the question. Okay, so the car is coasting down at constant speed, down an inclined plane, very simple. And then afterwards, the car can ascend the same slope with a maximum acceleration of 1 meters per second square. So first, they're telling you it's coasting down at constant speed, meaning acceleration is 0. But then they're saying the car can also, if it chooses to, go up the plane, so ascend the slope with an acceleration of 1 meters per second square. So it's talking about two different scenarios here. When the car is going down at constant speed, acceleration is 0, or when the car is going up the slope, okay, with an acceleration of 1 meters per second square. Right. Part A, find the total resistance to the motion, meaning find friction. What is friction? That's what it's telling you. Then part B, find the external force, find the driving force exerted by the engine when the maximum acceleration is reached. So essentially, your car is going up, right? So the car is going up. How much is the force? What's the magnitude of this force for you to get that acceleration of 1 meters per second square? So let's draw a diagram. There are two diagrams, or technically there are three diagrams that you want to sketch, but to answer part A, we only need the first diagram, okay? So that is when your car is just coasting down your inclined plane. Right, your inclined plane makes an angle of theta to the horizontal, and you've got the object, which is your car, down here, coasting down. So acceleration is equal to 0. Now, the forces affecting your car, we know there's always the reaction force, which is pretty much perpendicular to your plane. And then you've got the gravity, which is your weight force. And weight force in this case is m times g. We know the mass of the car is at 1 ton, which is 1,000 kilograms. Okay, so that's 1,000 times g. So 9.8. Right, that's the gravity, but always make sure you always draw your invisible triangle. That's crucial, okay? Always make sure you do that. Always make sure you do that. This angle here is theta. It's always the same as the angle that it makes with the horizontal, okay? Now, there's one more force that we're missing here, and that is your friction force. There must be friction, there must be a resistance force, or else if this car was just left by itself, it will just accelerate down. It won't be coasting at constant speed. There must be friction that is trying to, stop the car from accelerating downwards. It is still moving down, but it's not accelerating down, so it's just moving at constant speed, okay? So there must be friction. I'll call that Fr, okay? Right, so part A, let's go into solving part A. What do we need? We need to find Fr, pretty much, the resistance force. So how would you do that? Well, the forces affecting your car horizontally along the plane over here is your friction force going up, and obviously there is your force caused by gravity going down. Now, we know friction force is just Fr, we're trying to solve for it, but what about the force going down? What is that equals to? So the force going down this way over here is caused by this force right there, the gravity, the horizontal, one part of your gravity force. So if you draw a triangle, so this is your gravity, the magnitude is 1,000 G, it's going that way. The invisible triangle, there we go, this is the force we need, this force right here. The one going horizontal, we'll call it x, and this is theta, right? If you want to solve for x, then sine theta is equals to x over 1,000 g, okay? So it's opposite, x is opposite to theta. So therefore, x is 1,000 g multiplied by sine theta. That's how you solve for the horizontal force, given your weight force, the magnitude, okay? So the hypotenuse here. So if you do this, we know that sine theta is equals to 1 over 20 right here. See, sine theta is 1 on 20, so we just chuck in 1 on 20, and 1000 divided by 20 gives you 50. 50 multiplied by g, that is 490 Newton. Okay, so that's what the horizontal force is, 490 Newton. And we know friction force has to balance out with this force right here so that the object is just not accelerating either direction. Okay, so in this case, if they have to balance out, that means friction force must be equals to 490 so that they cancel each other out. That's it. That's for part A, guys. 490 Newton, that is your resistance force. Okay, let's have a look at part B. I'll just shift over to the right side. Part B, a little bit over here. So, part B, find the driving force exerted by the engine when the maximum acceleration is reached. Okay, so this is talking about the second scenario where your car is now ascending up the plane. So let's have a look. Draw your inclined plane once again. Okay, so I can't draw straight lines. Right there. Theta. Just get your object, get your car. Always draw the plane. Your book really, or your textbook, should have a lot of these planes. Because you always want to draw them, okay? It really helps when you can see it. So weight force we know is 1000 G, as always, same thing. Now you also got your reaction force, that's fine, we'll call that reaction force. And then you've got the external force, the driving force exerted by the engine. So I'll call that F, and exerted by the engine, so it's going up, okay? Because we know the car is accelerating upwards at an acceleration of 1 meters per second squared. So there must be some force trying to pull it up instead. So we call that force, just call it force, F, okay? Now in this case, in our previous scenario, friction was going up. In this scenario though, we know the car is going up and friction always opposes the motion. And because your car is going up, friction must be going down, okay? So friction, unlike the first scenario, it was going up. This way it's going down because your car is now going up. Just think of that friction as that little brat who always opposes the teacher, okay? So that's what friction is. And then don't forget, whenever you draw an inclined plane, always get that invisible triangle. It's very important because that is telling you this horizontal force right here. Just remember, there is that horizontal force always trying to pull the object, the car down, okay? So let's have a look. What are our forces here? We've got horizontal, we've got the driving force, but then you also have your friction force going that way, and you also have the gravity trying to pull it down as well, which we know is previously as mg multiplied by sine theta, right? So the 490, okay? So 490. Okay, so in this case, let's calculate. Let's calculate what our force is. We know it's going up, so force has to be bigger than both of these combined, right? So net force equals to ma, Newton's second law of motion. F has to be bigger than the other two combined, so it's friction. So it's F minus your friction force, and then minus the force going down caused by gravity, which is 490. So this force right here, and that is equals to mass, which we know is 1000. Times by acceleration, we know going up is 1 meters per second squared. Okay, so just plug in the numbers. Let's have a look. Our force is just F. We're trying to find it. Our friction force, in this case, what is friction? Friction we found in part A as 490. So it's just now this time friction is going the other way. Friction is constant. It doesn't matter where you're going up or you're going down. Friction stays the same magnitude. It's just the direction is different. So friction is 490, but it's just going the other way instead, okay? And then you minus it by another 490, your gravity, equals to 1000 times 1, so that's just 1000, and then you just solve for your force. So force is equals to 1000 plus 490 plus another 490, and your final answer, guys, is 1980 Newton. So that is how much driving force the car needs to exert so that you are accelerating up the slope at 1 meter per second squared. So guys, hopefully this video today helps you solve for question 15 in chapter 13C, inclined plane chapter. And if you did find it useful, please leave a like. That would be very much appreciated. But aside from that, thank you for watching, and I'll see you in the next video.